Hey, Algebra 2 students. Welcome. This is Mrs. Williams, and this is the Unit 4 review. We will not start at 2:35. We will start right now. But unfortunately, my PowerPoint would not load in Class Connect, so we are doing it this way. I'm just making a recording for you guys. If you want to watch that link on the window right here, it's just kind of a fun video on hybrid cars and how that relates to these inequalities that we're talking about in Unit 4. Before you get started, you pause this if you need to. Grab some graph paper if you don't have any, because I want you guys to work out these problems as we go along. And what I'd like you to do, I'm not going to put in the pause in the video because now that it's in recording form, you guys can hit the pause button. But what I'd like you to do is to pause it and try these problems on your own first. Just give it a shot. Don't stress if you don't get it right or not. It's kind of like a pre-test, so you know if you're ready for your Unit 4 test. So try it on your own, and then watch me do it and just check your work. Make sure you did it right. Okay? If you need some graph paper, there is some in doc sharing. Okay, so it'll say coordinate graph paper. All right, so here's 4 problems on the screen. And questions 1 through 6 on your test are very similar to these. So this one screen is going to cover 6 questions on your test. So you need to know these well. A big thing you want to know for the test is interval notation. So we're really going to work on that on this screen. All right, so the first problem up on the board is x is less than 2. The directions say express the solution in interval notation. So let me grab a color here and we'll get going. Let me change the thickness. All right. So I know the directions just ask you to write this in interval notation, but what I find makes it easier, rather than jumping straight from here to interval notation, is to graph what this means first. And it tends to be easier to go from the graph to interval notation. So here's how you graph it. First, you want to pay attention to your inequality symbol. If it is strictly less than or greater than, you're going to put an open circle. So I have had questions about that. That's where the open circle comes from. It's just the sign. If it's less than or greater than, it's open circle. So I'm going to put an open circle on 2. And then the open side of the inequality, whatever's on that side, that's the bigger stuff. So this is the big side. 2 is the bigger number. And then these are, x represents the number smaller than 2. So when I shade this number line, I want to shade to the left because all the numbers on the left side of 2 are smaller than 2. So that's what that inequality is saying. Now, we graphed it. It's easier to go to interval notation. What you want to do for interval notation is you want to note your boundaries. The boundary on the right is a 2. The boundary on the left over here is negative infinity. The arrow means that it keeps going and going and going forever and ever and ever, and we call that negative infinity. Now you can't ever get to negative infinity because anytime you think of a really big number, you can always think of another even bigger number. And then you can always think of a number even bigger than that one. So you can't actually ever get there. So with interval notation, we put a parenthesis. Parenthesis means that you don't actually ever reach that boundary value. So if we look at 2, which is on the right side of our boundary, we're going to also put a parenthesis there. And the reason is because of this open circle. The open circle means that you can't actually ever get to 2. It means you can get up to 1.999999999999999, but not to 2. So that's what the parenthesis means. It just is the same thing really as the open circle. And then all you do is put a comma in between. So if you're actually going to write this, you wouldn't leave so much space. You would just put it close together like that. And that would be that first answer in interval notation. All right, let's move on to the next one. I'll switch colors. Again, I'm going to graph each of these inequalities. I really have 2 inequalities here. I have a is greater than or equal to 12, or a is less than or equal to negative 4. So I'm going to just take one of those at a time. A is greater than or equal to 12. Again, I'm going to look at the inequality sign. Because that is greater than or equal to, I have the equal to there this time. That's when you put the solid dot. So I'm going to go to 12. Oh, I guess I got to make a couple more tick marks there. And I'm going to put a solid dot on 12. Okay. Now, the alligator mouth likes to eat the bigger things. So this means I'm trying to show all my numbers bigger than 12. So I probably should have left myself a little more room, but I'm just going to shade to the right. Okay, and I'm going to make that arrow nice and big and thick to show that that actually keeps going forever and ever to the right. Sorry about that phone ringing there. Okay, and then I'm going to jump over here, if I can find my mouse, there we go, and I'm going to graph this other one. So again, because it's a less than or equal to, so it's really just that equal to that you want to pay attention to. If that is present, you put a solid dot. So a filled in circle on -4. And I want to show A as less than or equal to that. So in other words, this is my bigger value. -4 is on the big side. The A's, the numbers that make this inequality true, are smaller than -4. So I'm going to shade to the left because these numbers are smaller than 4. Okay, so now to the interval notation part of it. You're going to do what we did on the first problem, but you're going to have to do that for each piece of this graph. Okay, so first let's focus over here on our left piece. Again, we're going forever and ever to the left, which is -infinity. You can't get there, so it's a parenthesis. Put your comma, and then we're going to put in the other boundary, which is -4. Now, because of the solid dot, I can actually equal -4. -4 is part of my solution set. It includes -4, so I put a bracket. That's what the bracket means. Okay, so parenthesis means it can't equal the value, bracket means it can. Now let's go over here to this side. Okay, so 12 is on my left side of the boundary. I keep going forever and ever and ever to the right, which is +infinity. That's my boundary on the right. I can't ever equal infinity, whether it's positive or negative, so I put the parenthesis, and I have a solid dot on 12, which means I'm going to put a bracket. I can equal 12. Now, because I have two different interval notations here, I have to combine them. This is where the right side up U or the upside down U come in. And I know there's a lot of confusion on this. How do I know which one to use? If you see the word or, you're going to use the right side up U. Another big indicator is whenever you see a gap. If you've actually graphed and you see a gap in your graph, there's like a line over here and an arrow, with a line over here. There's in between, there's nothing, it doesn't overlap. That's an or. And you're going to use a right side up U. Okay? So my final answer would look like this. I'm going to write -infinity, comma -4 together like that. And then I'm going to write my right side up U and then 12, comma infinity. Okay? That would be interval notation there. All right, now down here, on this one, what I have to do first is I have to solve for x. Okay? So for now, I'm just going to kind of pretend like this is an equal sign. I'm going to try to get x by itself. So first I would subtract 6. That's going to leave me with 2x is greater than or equal to 2, and then divide by 2. Now remember, if you divide or multiply by a negative value, you switch your inequality around. Here I did divide, but it wasn't by a negative number, it's by a positive number, so I'm going to leave this alone. Okay, but just in case you had a problem like that, you would just flip that. Instead of a greater than, it'd be a less than. So my inequality is x is greater than or equal to 1. So I'm going to put a solid dot on 1 because I do see the equal to part right there. And then this is representing the bigger numbers. It's on the open side of the alligator mouth, so these are the numbers bigger than 1. That's another way to say that. And all the numbers to the right are the numbers that are bigger. So I shade that way. And then I write my left boundary, my right boundary. I cannot ever equal infinity, so I put a parenthesis. I can equal 1. And then I put a comma in between. Okay, so you could rewrite that without all the space in here, and that's your final answer on that one. Here, what you really have are two inequalities. Let me find a fun color to use. Here we go. I don't know if it's fun or not, but it's green. If you have a number on the left, number on the right, you see two inequalities and then some stuff smushed in between. This is an and inequality. Okay, so up above, right above up here, we had or, and that was the right side up u. Now we're going to have the upside down u, okay, if needed. Now sometimes you don't need that symbol. It depends on what the graph looks like. That's what I say. It's really, really hard to do these without graphing them on a number line first and then going to interval notation. Okay. Before we can graph this, though, we actually need to break this into two inequalities. So this really represents the inequality on the left side and on the right side. So we really have two equations. So we have -5 is less than y minus 6, and we have y minus 6 is less than 2. So over here, if we solve for y, we would add 6 to each side, which would give us a +1. Same thing here, we're going to add 6 to each side, but 2 plus 6 is 8. Okay, we're going to graph each of those. So we're going to put an open circle on one, because we do not see the equal to right there. It's just strictly a less than. And this means my answers to this inequality need to be bigger than 1. Okay, so my solutions, my numbers that make this true are bigger than 1. Those are the numbers to the right. So I shade this way. This represents the numbers smaller than 8. So I'm going to put an open circle on 8. And I'm going to shade to the left. The numbers smaller than 8 are to the left. There we go. Now with an and, you're looking for the overlap. So my graph overlaps from here to here. See how there's a line above and then a line below? That's where those two answers are overlapping. So that is the part that I write as my answer. So this is not part of my answer. And over here, this is not part of my answer. With and inequalities, you just look at the part where they overlap. So once you figure that out, it's like the others. You look at your left boundary, which is 1, your right boundary, which is 8. We can't get to either of those. Neither 1 or 8 are part of our solution set because of the open circle. So we put parentheses and then a comma in between. And that would be your answer. So notice on this one, we did not need this symbol. Sometimes you will need this symbol with an and inequality, but just remember, and basically it would be if you have two separate sections of the graph. In this case, they overlapped, so you just had this area in the middle of two numbers. So if you have an area in the middle of two numbers, you won't need that symbol. Okay, so that covers a lot of what you'll need for questions 1 through 6 on your test. Okay? Now here we have a couple different questions. These are going to help you on questions 6 through 9 on your part 1 and question 1 on your part 2. Okay? The directions say express the solution in interval notation. Okay, so let me change colors again. Here it's very similar to the last slide, right? Directions are the same exact thing, actually. We're still trying to get to interval notation. The problems start out a little differently, though, because of the absolute value. Okay, so they're really similar. Other than that absolute value, you still have an inequality. The thing to remember with absolute value inequalities is this very similar to the idea when we had absolute value equations with an equal sign right there, is that you are going to have two parts to this problem. Okay, the first part is really easy. The first part, you just drop the absolute value. So you rewrite this problem and solve this problem without the absolute value symbol. Okay, the other part to this problem will be dropping the absolute value, but then you have to do two extra things. The first thing is you have to change the direction of your sign, and you have to make your answer the opposite. Okay, so make it negative. Okay, so we have two separate equations there, and we're going to solve each of those first. Okay, and then we're gonna put it on our number line. So here we are going to add 8 to each side. So I would have 4x left over here. If I add negative 16 and positive 8, I get negative 8. I'm going to divide by 4 on each side, and I'm dividing by a positive, so I don't need to switch the direction of my inequality. But I would get x is less than negative 2. Okay, let's go back to this other one. Same process. I'm going to start out by adding 8, so I'm going to have 4x is greater than, in this case, so my 16 over here is positive, and if I add 8, I'm going to get 24. Then I'm going to divide by positive 4 on each side. I don't need to switch the direction of my inequality because I'm dividing by a positive number. But I'm going to get 24 divided by 4, which is 6. Okay. Now I'm going to graph, just like I did on the last slide, open circle on 6. X is on the open side of the alligator mouth, so I want to show the numbers bigger than 6. On this one, I'm going to put an open circle on negative 2. And these are the numbers smaller than negative 2, which is to the left. Okay. So we write our interval notation. We have negative infinity as our left boundary, and we can't ever equal negative infinity. We have negative 2 as our right boundary, and we can't equal negative 2 either because of the open circle. Over here, we have 6 as our boundary on the left, infinity as our boundary on the right. Parentheses on both sides. Can't equal either boundary. Can't get to either boundary. Now, the question is, okay, I have two things of interval notation. I need to know whether it's going to be a right side up U or an upside down U. That's how you join if you have two different parts to your graph in interval notation. You need to join them somehow, either with a U or an upside down U. Okay? So how do you figure that out? Well, I gave you a hint up here on the screen, and we talked about this last week as well. It just goes back to your original problem, and if the sign is a greater than sign, it's an or. Okay? If it is a less than sign, it's an and. And you can think of it as less than, and that'll help you remember. Okay? So you see less than right there, but just add a D to the end. Less than is and. So if it's a less than sign, it's going to be an and the and goes with this symbol, the upside down U. If it's a greater than symbol, you're going to put that in between. Okay? If we look at this problem, it's a greater than symbol, and so to join these, we're just going to put a right side up U. Okay? So you probably wouldn't want this space in here. You just bring the left and right sides together there, and that's your answer. The next one is very, very similar. You're going to, again, have your two inequality equations. The first one, just that, drop the absolute value. Let's go ahead and solve this one so I don't have to switch colors. You're just going to add 4 to each side. So you're going to have x is less than or equal to 16. Okay? The other equation is going to be, again, dropping the absolute value, but remember you have those two things to do. The first thing is to switch the direction of the inequality and to change the sign, like so. And then to solve this again, just add 4. If you add 4 to negative 12, you end up at negative 8. Okay, so go ahead and graph these. We're going to have a solid circle on negative 8, and my numbers that make that true are the numbers bigger than negative 8. Like so. And then we're going to have 16. Oh, should have made my number line a little longer. Let's say that's 16 right there. we're going to have a solid circle on 16, and my solutions are the ones less than 16, so I go that way. Okay, so let's think about this problem for just a second. Let's rewind back to the very beginning. Again, we want to look at that inequality symbol in the original problem to figure out if it's an and or an or problem, right? And that's a critical question. You have to ask that. But because it is a less than, it's a less than or equal to. But if it's a less than or equal to or just a less than, same category, it's an and. So remember, when you're graphing an and, the solution is just the overlap parts. So see how the red and the blue lines, oh, sorry about that. I should have made my number line longer. That's what's messing me up there. Oh, I don't want to delete. There we go. Delete that green mark there. It actually goes all the way over to 16. And it probably would help. Okay, let's go back and look at this one again, because I didn't have my 16 on there when I did that. This actually would keep going, right? All these numbers over here still. So you can see that the blue line and the red line both cover all the numbers between -8 and 16. So that is, that's my answer here. So from -8 to 16. So I would write my interval notation like this: -8, bracket on the -8 because I have this solid dot right here. It can equal -8, comma 16. That's my boundary on the right, a bracket there. Okay? And that would be my final answer there. Okay, here. Question 10 is similar to this question on your part 1, and then actually similar to this one on the right, and then your question 2 on your part 2 test is similar to this one. And they're very similar questions. They're kind of the opposite of each other. So this one, you have the equation, you have to supply the graph. On this one, you have the graph, you have to supply the equation. Okay? So they're kind of the opposite idea. So let's start with this one. We're going to graph this line. Okay? Now notice, this is kind of nice. They were easy on us. They gave it to us in y equals mx plus b form already. So remember, your slope is the number, the coefficient in front of x, so 1/2. Your b value is -4. And what your b value tells you is it actually gives you a point, and the point is always going to be 0 for your x, and your y value is just whatever the b value is. And you do take that sign to the left of the number. Okay? So you're going to plot that point first. So I go down to 0, -4. Then you use your slope. The slope says +1 over 2. So you're going to go up 1 from where the point you just graphed. You're going to go up 1 and to the right 2. And you can keep doing that if you want to. Up 1 to the right 2. Up 1 to the right 2. Okay? Alternately, just to throw something else at you, you could also go down 1 and to the left 2. Because if you have -1 over -2, that's actually the same thing. A negative divided by a negative is a positive. So just a little extra something there for you guys that I'm sure you are really excited to learn. But you can also do that. And then since we know this is a line, all you have to do is connect the dots, right? If you have at least 2, I didn't have to do all of those. All I had to do was 2. Make my line a little, if it'll cooperate there. There. Okay, let me make it a little thicker so you can see it. There. Okay? So there's my graph. Now, be careful. Don't forget, we are in Unit 4. We are not in Unit 2. Unit 2, we had an equal sign right there. If it were an equal sign, we'd be done. Okay? We are in Unit 4, and we're talking about inequalities. We are not done. Inequalities always require shading. Keep in mind what we did on the last 2 screens. We had number lines and we had to shade them, right? Because of the inequality. Inequalities mean there's more than one number that would work. Okay, so same thing on the graph. what you do to figure out where this gets shaded is pick a point. Now the easiest point to pick is 0, 0. And you're going to test it. Now the only time you can't pick 0, 0 is if your line actually goes through. So say my line went through 0, 0. I wouldn't be able to pick it. So don't pick a point on your line. You have to pick a point to the left or the right of it, or above and below, however you want to think of it. Okay. In this case, I can pick 0, 0. It wasn't on my line. So let me switch colors, and I'll show you what we're going to do with that. What we're going to do with that point, this is our test point. We're going to test 0, 0. And what I mean by test it is to plug it in. So I'm going to plug it into my original problem. My y value is 0, my x value is 0. So if I plug it in, it's going to look like this. 0 is greater than 1/2 times 0 minus 4. Not sure why it's so slow there. Anyway, I guess it eventually fills in. Okay, then simplify. So I have 0 over here, nothing to simplify. 1/2 times 0 is 0. 0 minus 4 is negative 4. And you ask yourself, true or false? Okay, this statement is true. 0 is greater than negative 4. If it's true, I look on my graph, I say, there's 0, 0. And that point made that equation true. What that means is that all of the points over here in this region make that equation true. So if you don't believe me, try them all. You'll be working for quite a while. But you can double check yourself. If you want to pick another easy point like 1, 1, plug it in. If it's true, then you can be sure you didn't make a mistake. But it just means that 0, 0 worked, so everything else over here on this side of the line is going to work too. And so how we show that is we just shade it in. Just like we did on the number line, except now we just have a lot bigger area to shade. We just shade all of this in. It just means, what the shading means is that any point that you pick over there in that shaded part, if you plug it into this equation, it's going to be true. Okay? So over here, we're asked to write the inequality represented by the graph. Well, the first thing you want to do is you want to write the equation of your boundary line. So the easiest way to do that for this particular line is just to go ahead and identify the y-intercept and the slope. So we can see right here, let me grab a different color. It's red. That's where our line crosses our y-axis. So we want to look at the y value there. The y value there is -1, -2, -3, -4. That is our b value. Okay, and then we just need to find another point on this line that matches or that crosses, where we can actually tell. So in other words, we don't want to pick this one. It's kind of in between there, and we can estimate that it's like at -1/2. But it's best if you can find a point like this where it definitely crosses the crosshairs. So let's try that point, and it looks like even this point would work too. So from here, what would we do to get to this point? Well, we would go up 2. That would be a +2 for our rise. And to the left one, which would be a -1 for our run. And remember, we always do, I like to spell it like this, rise over run, because I know that you don't spell rise like that, but it helps you remember the y values go in the numerator. Now in this case, you don't. This is helpful if you have 2 points that you're trying to solve for the slope. Here, it's easier to see when you have a graph. This is your rise. So 2 is your numerator, -1 is your denominator, and then 2 divided by -1 is just -2. So we can simplify that. That's our slope. Okay. So our b value is -4. Our m value, our slope, is -2. Now we just have to plug it into y, and I'm going to not put it equals because we are dealing with an inequality. So y less than or greater than is going to go here. Mx plus b. So let's fill in those values. We're going to have y blank negative 2x minus 4. Now, if you, some students can look at this visually and figure this out. Since the shading here is on the left side of the line, these numbers over here, you can think of those as less than the graph. And because this has a solid, this is a solid line, it would be less than or equal to. Okay? And that's kind of the way you look at it. Oh, actually, that reminds me, over here, I actually forgot to mention something. Right here, it's hard to do in PowerPoint, but I actually should make this a dashed line. And the reason that I should make this line dashed is that if you look at the inequality symbol in the original problem, it is strictly a greater than. You don't have the equal to down here. So if it's a greater than or less than, you want a dashed line. And if it's greater than or equal to or less than or equal to, then you want a solid line. Okay, so that should definitely help you on question 10 of the part 1, which is similar to this question here. You're going to have to be able to write the line, the equation from the graph. And then on your part 2, question 2, is similar to this. You'll have to take the equation and draw the graph on your own. All right, this slide says, which ordered pair is a solution to the system? All right, you have two equations. It's called a system of equations if you have more than one, in this case, system of inequalities. And you have some points over here. Well, the easiest thing to do is just to plug those points in to the equations and see which one makes both equations true. So I'll show you that in a second. The other way to do this is to go ahead and graph the lines. So if I have x is greater than or equal to negative 4, if you have x equals a number, that is a horizontal line at that value. So I go over to 1, 2, 3, 4, negative 4, and I make a vertical line. Did I say vertical or horizontal? It's a vertical line. Sorry about that if I misspoke the first time. Oh, I guess I could have changed my line on the last one to a dashed line. Oh, cool. Well, now I know. Okay, so this would be x equals negative 4. Now remember, if you have the inequality, that you have to go ahead and shade it. Since this is x is greater than negative 4, I would shade over here on the right side. These would be the numbers. And again, if you're not sure, always test a point. So I could plug in the point 0, 0. And there, I only have the x value of 0. If I chose the point 0, 0 to test, I would just have the x value of 0 to plug in. But 0 is greater than negative 4. So that would again tell me that point makes the equation or the inequality true. And so I want to shade the side of my line that contains the point 0, 0, which is right there. Okay. Now I can go and graph my other line. Y is less than 2. So y equals a number is a horizontal line at that value. So I go up to a y value of 2 and I make a horizontal line across here. I'm going to go like this. Let me change that so you can see it. There we go. Make this one a little bit thicker too. There. Okay, and then you probably guessed this is the number smaller than 2, so you're going to shade underneath, but again you can always test the point 0, 0, and again you would plug in 0 for y, and 0 is less than 2. That makes it true, so you want to shade the side of the line that contains that value, which is underneath like I'm doing. Okay. Now you see how I have a bunch of colors going on, right? Well, the solution, there's more than one point that's a solution to this system, but we want to figure out which one of these is the solution to this system. The one that's the solution is going to be the one in the area where they overlap. So see how this, when I shaded in, oh, sorry about that. When I shaded in my light blue and my pink, this dark blue here is where they overlap. So this is my overlap area, and this is, any point in here is going to work in both of these equations. That's what it means when it's a solution to the system. It means it's going to work in both equations. So we could just visually look and say, okay, which one of these points is in that area? 3, 4, let's look at that. 1, 2, 3, 1, 2, 3, 4. Nope, not in the overlap section, so it's not A. B, negative 10, 11. Negative 10 is going to be way over here, or negative 10, 1. But negative 10 is going to be over here, up 1, no. That's not in the overlap area. Is C going to work? Well, let's look at negative 4, 2. So we go over 1, 2, 3, 4 to the left, up 2, 1, 2. Now this one's a tricky one because the lines overlap there. But remember, we are just looking for the number that is less than, so you're wanting to look at the shading. Sorry about that. And so that actually, even though it falls right on the boundary, is not going to be a solution to the system. Let's look at D. D is 5, negative 1. 1, 2, 3, 4, 5, down 1. Yep, that's the one we're looking for. That's definitely in that dark blue region. Okay? Questions 11 and 12 on your Part 1 test are really similar to this one. Okay, next question. This one says, graph the following inequalities to determine the solution set. And question 13 is really similar to this one on your Part 1 test. Okay, so on this one, the easiest thing to do, you have your graph and you're trying to match this graph to one of these answers. And on your test, it won't have 3 different colors. You'll just have one shaded area. So the part that we're looking at, the answer, the solution set, is this dark blue area. Okay, so kind of ignore the pink and the blue. That was shading from the other 2 graphs, but that's not the final solution set. The final solution set is the dark blue area. So the easiest thing to do is just pick a point in that dark blue area and plug it into each answer, A, B, C, and D, and see which one ends up being true. So try to make it easy on yourself. Let's pick, let me get a different color so you can actually see what I'm going to pick. I'll do yellow, that should show up. Pick something easy like on the x-axis, the y-axis, because one of your values is going to be 0 that way. So let's say we pick like this point. And it doesn't matter. You could pick this one if you want to, or this one, or something in between if you really want to be a masochist, make it hard on yourself. But I'm going to pick that one, so let's write down what that is. That is the point 1, 0. So that means I'm going to plug in an x value of 1 and a y value of 0 until I get the one that's true, and then I know that that's my answer. So for A, my y value is 0, and I'm asking myself, is 0 less than or equal to 1? Check. Yes, it is. Okay, so then I'm going to move on to my second equation. My y value is 0, my x is 1, so I'm going to have 0 minus 1 is less than or equal to 0. 0 minus 1 is negative 1. Is that less than or equal to 0? Yes. So I actually made it really easy on myself and chose the correct answer the first time, A. But let's go through why the other ones would not be true. So this one, you can just look at it right off the bat. The very first thing would throw up a red flag. If you've already done the first equation in part A, you know that this is true with the direction as a less than or equal to. If it's greater than or equal to, you know right away that's not going to work. So don't even waste your time on B. Just think about it really quickly. Don't try the second equation. If the first one doesn't work, don't even worry about the second one. Okay, choice C. Now the first equation, if you'd done part A, and let's say, for example, A didn't work out on the second equation, you do already know that the first one works, so you don't have to redo that one. It's the same equation. but then you would plug it in here. Okay, test the second one. Now we know this should come out to be false, right? So you would have 0 minus 1 is greater than or equal to 0, and that does come out to be false. Negative 1 is not greater than or equal to 0. Okay? And then you just continue in that manner. But you just are checking to see the point that you picked that's in the shaded region in the solution set works in both equations. Okay, now there is going to be one where you, and I think this is the part 2 test number 3, where you have to actually graph this. Okay? Alright, so take one thing at a time, take a deep breath, and we're just going to first graph each of these lines. And we've done this before on a previous problem, so you can do this. Let's look at this first equation. It's already in y equals mx plus b form. Okay, so in other words, this is your slope, this is your y-intercept. It's ready to be graphed. So we're going to go to our y-axis, go up to a value of 2, fill that in there. Okay? Then we're going to use our slope. Our slope, we can think of it as negative 3. We can associate the negative with the numerator or the denominator. It really doesn't matter. Just don't do it to both. Okay, so just put it with one or the other. So I'm just going to do negative 3 over positive 2. That's how I'm going to think of it. So if I'm thinking of it as negative 3 over positive 2, that means I'm going to go down 3, 1, 2, 3, and to the right 2, 1, 2. Okay, and I can do that again if you want to make sure your line's nice and straight and accurate. Down 3, right 2. You really only have to do 2 points. Now the second thing that I also want to note is whether my inequality sign is a less than or equal to or just a less than. Okay, in this case it is less than or equal to. So once I get my graph lined up with my points here, I can just leave it as a solid line. Okay, and on your part 2 test, I've had a lot of questions about, well, I don't how to draw. I don't know how to draw on my computer. Well, what I'm doing right now to draw is, if you are in PowerPoint or a Word, which Word would be probably your go-to choice there, check the Review tab and then go to Start Inking, and you should be able to, if you have the right add-in, you should be able to use your mouse like a pen. If you don't have that capability, don't worry about it. Print out your Part 2 test, write it out by hand, take a picture of it with your phone, or scan it into me and put it in the Dropbox. There's shouldn't be a reason why you can't do that. If neither one of those options work for you, you can also use a paint program. Pretty much any computer has a paint program on it, and you can search for it in your program list, and it'll let you draw on your computer as well. Okay, so don't not complete your part 2 just because you feel like you don't have anything to draw with, because you can always use your paper and pencil. Okay, so now on this other one, it is not as easy to graph because it's not solved for y. It depends on what you prefer. You can definitely solve this for y, or you can make a t-chart. I would prefer to just solve it for y. So I'm going to subtract x from both sides to make that cancel. I'm going to have 2y is less than negative x plus 4. Then I'm going to divide by 2, and you would just divide everything by 2. The 2 here will cancel, and you'll get y is less than negative, and there's really a 1 in front of the x, so you can write it like negative 1/2 x, and 4 divided by 2 is 2, so plus 2. Okay, so then it's just like this other one. You're going to take your b value of 2. It's actually going to be in the same spot, but your slope is different. Your slope is negative 1 over 2, so you're going to go down 1 and to the right 2. Down 1 and to the right 2. Down 1 and to the right 2. Okay. Alternately, like I was saying before, you could also put the negative in the denominator. So just as long as you put it in numerator or denominator, don't do it in both places. But you can also think of this as up 1 to the left 2. So you'll see these will line up, okay? So up 1 to the left 2. So see how these are all still in line? So you can think of your slope either way. Okay, so let's get a line going there. Okay, there we go. Now, the thing is here, look at this inequality. This is strictly a less than. So now that I discovered I can do this, let's see if it'll work. I think I can make this a dashed line. Look at that. Okay, but that's when you're going to make it a dashed line is if it is strictly less than or greater than. You don't have the equal to. If it has the equal to, greater than or equal to, less than or equal to, you make it a solid line. We're not quite done. We are almost there, though. All we have to do now is test a point in both equations. And again, this one doesn't go through 0, 0, so that's the easiest one to pick. I'm going to use red for my top equation to test it. So I'm going to take, I'll just do it over here, plug in 0, 0. So I have 0 would be greater than or equal to negative 3/2 times 0 plus 2. 0 is going to be simplified to 0. Can't do anything with that. But here, when you multiply, all of that goes to 0. So you have 0 is greater than or equal to 2, which is false, right? That is not true. And so if I look at the line, remember this line right here, my solid line, represented that equation. Because 0, 0 made it false, I don't want to shade over here. Because if I shade over here, I would shade the point 0, 0. I want to shade over here to the right. Okay, so I would just, and you can grab your highlighter or do it like this, as long as it's clear that you're shading, you know where you're shading. Okay, fill all that in. All of those points in there are your answer. Okay, now to test the other one, let me switch back to green. Okay, and you can plug it into the original, you can plug it into your, you know, if you solve for y, it doesn't matter, it's the same equation. Let's say I just plug it in right here, okay? So I would have 2 times y, but now since I'm plugging in 0, 0, y is 0, plus 0 is less than 4. If we simplify that, 2 times 0 is 0, that's gone, plus 0, well, you get 0. Is 0 less than 4? Sure is. So we're going to shade the side of the line. Remember my dashed line represented that one. So rather than shading above, I'm going to shade below, because if I shade below my line, see how I'm going to have this point 0, 0 shaded in. Okay? So I'm just going to do a highlighter this time. I'm going to shade underneath here like this. All of this underneath here. Okay? Fill it in. Okay? Now your final answer, you shouldn't leave it probably like this. It's kind of hard for me to erase it. Well, actually, let's try this. Okay, your final answer is the overlapped part. So actually right here, it's kind of like a triangle looking shape. Right in here, see how my red line and my green highlighting overlapped? So go back and, oh, see, it erased all that. Okay, so I can't really, let me hit undo. There we go. I can't really do that very well in PowerPoint, but if you're doing this by hand, or at least, you know, like if you did do this in a Word document, explain to me that pink, the dark pink area is my final solution set. Okay? So the final solution is where the two overlap. So I hope that helps. Good luck on your test.